welcome to my talk about AI agents. Today we are going to look at them from a slightly different perspective. Very often people like to kind of start with a framework like LangChain or Crew AI or something like that. But I'm quite convinced that AI agents technically are kind of trivial. So we don't really need the frameworks. We can just implement them ourselves directly. But actually, this talk should actually be called more like no frameworks, just code, and a lot of pitfalls. Because even though I think they are trivial, there's a lot of mistakes that you can make along the way. So let me introduce myself. I'm Paul. I've been a speaker at MLCon multiple times. And I'm the CTO and co-founder of Express AI in Japan, where we are working on creating agents that are about as reliable as a regular computer program. And yeah, over the last 20 years of software development, I've learned a lot. And over the last 10 years, I've in particular also implemented a couple of those AI agent frameworks. Two of them are actually published as open source, one being a graphical thing, another one being more of a dependency injection thing for agents. And even a couple ones that, well, have to stay closed source because they were client projects. So I do know a thing or two about AI agents. So now, let's define the terms. What even is an AI agent? Because there's so much marketing going on that as long as someone or something shows you a pop-up that says thinking, they will happily call that AI and agents. But what even is an agent? The definition that I like to go by and that is quite commonly well accepted is for something to be an agent, and note not an AI agent, just an agent. We need something that can perceive its environment with some sensors. It needs to be able to work in that environment, to interact with that environment with actuators. It needs to have a goal so that it can work towards that goal. And in typical coding fashion, there will be some spaghetti code to put all of that together. So, and if we do put all of that together, what do we get? The flying spaghetti monster. It really is an ideal representation of how most agents exist these days. They can look at their environment. They can use their noodly appendages to modify it. They use some kind of black box, LLMs in particular, to process it. And then it's all hooked up with some code that nobody really fully understands. But more seriously, agents are essentially everywhere. The humble thermostat that you may have in your hotel room or at home is technically an agent because it satisfies those requirements. It can sense the temperature, so it can check its environment. It can change the temperature by turning on the heater or turning on the AC. And it will, well, it does the processing in just comparing the temperature with a set point. And then its goal is to maintain the temperature that you want it to maintain. And it doesn't even need to be some highly sophisticated computer processing thing. It can even be literally the knob that you have on the radiators, like literally right here. You have on the radiator a knob that has a thing that will react to the temperature, it will expand or it will contract, and through that it will control its environment by changing how much heat output there is. So when you come home after the conference, you can look at your radiator and say, I have an agent in my home. No need for this fancy IoT stuff anyway. So okay, agents are everywhere. But what is not an agent then? A simple program that just calculates some stuff, that gets an input, produces an output, is not an agent. ChatGPT, especially the very early one, is not an agent. A simple chatbot that just talks to you is not an agent. Because you could argue, reading the prompt, that is a sensing act. maybe. But then it just calculates a response. Unless you add something to it to be able to interact with the environment, and unless you really give it a goal to do something, it doesn't satisfy the requirements. So how do we turn this together? Like how do we take the AI and the agent part and put it together? For what I want to show today, it's all about the AI driving the progress. That is, that it's not just using AI as a part of a step, it actually needs the AI to be the main driving force behind making progress towards that goal that we wanted to have. So the thermostat, as nice as it is, it's not an AI agent. There is no artificial intelligence involved in it. It's mostly a mechanical process or a deterministic program process if you have something that is a bit more modern, like a Nest thermostat. But also workflows are not agents, or not AI agents, because even though they use AI as part of things, just letting summarize text or so, because the AI isn't driving the progress, it doesn't become an agent through that. So, pitfall number 1. We haven't even started thinking about code, and we get to the first problem when it comes to implementing AI agents. Do you even need an agent? Creating an agent, if you don't need one, is just a great way to shoot yourself into the foot by creating complexity that's not necessary. So, if you need to create something that just uses AI as a step in a longer deterministic process, just create a workflow. There's no shame in that. Actually, create a workflow and be happy with your day because you don't have to debug complex stuff. But if you have a process that is more complex, if you have a process where the decisions that it needs to make are based on the inputs that it collects along the way, based on the sensors, based on the information that it collects from its environment, then you probably want to have an agent. And that also happens very much if you want to have something that gets emergent capabilities, that it can do things that you didn't even think it could do by combining the tools that you give it. So, first step was, first pitfall, things can be unnecessary. So, let's say we say it is necessary to have an agent instead of a workflow. Now we have to prepare ourselves. We have to collect the ingredients, do the mise en place as every good chef would do. And our ingredients here are very simple. As I said, there's no framework. We start with an idea for the AI agent. We have to at least have a simple understanding of where we're going with that. Then we need a programming language, something that we can use to make to implement our agent. Here we're going to use Python. The main reason for it is that many people know it. It's as close to executable pseudocode as it gets. And we have a very comfortable AI or LLM client in there. For the demo today, I'm going to use the OpenAI client, even though it isn't necessarily, you don't have to use an OpenAI model with that client. Because its API has been around for kind of the longest, many third-party providers support it. So you can just change the base URL for your LLM client, and then you can use different models, others that were not created by OpenAI. So now that we have the ingredients, the one model that is missing, or the one ingredient that's missing is the model, right? And that takes us to the next pitfall, choosing the right model for your problem. So if you use something that doesn't support the language that you're going to use to interact with it, then you will likely get the situation that it won't work as well. Or if you take something that cannot use tools. As I said, by definition, we want it to drive the progress. And in order for it to be able to drive the progress, we need it to be able to choose a next step. And choosing the next step is the easiest done by letting it choose a tool to call, whether it wants to sense the environment or whether it wants to interact with the environment, so to say. It is technically possible to make models that weren't trained to do that. However, if we do it that way, it is usually a bit more brittle. You get into a lot more complexity than is really necessary. So just pick a model that can use tools and understands your language, and that should make it work a lot better. And we get to the next pitfall. Take a model that can do the thing. Well, many people will just go and take the biggest, newest, most capable model that they can get their hands on. However, that will be slow. It will be expensive. It isn't necessary that you actually take that model. Instead, pick something, usually the cheapest and fastest thing that you can get, and then go up, only if it disappoints you with its capabilities. So you kind of have to make this trade-off between speed, cost, capability, and I suggest that you really start with the cheap and fast models, because then, if, for example, OpenAI doesn't want to play with you anymore, it's more likely that you can self-host something that is comparable to it. Now, we have that. We have kind of seen a couple of pitfalls, and I've said we need our ingredients. At first, they're a bit abstract. For today, we are going to go with something that will resemble a personal assistant that can access my calendar, can add things to it, can remove things from it, that can check public transport information, weather information. So I can ask it questions like, do I need an umbrella when I go out today, or something like that. And it will know where I'm going and things like that. Then the LLM that we are going to use will be GPT-4o Mini. It's a small and fast model. And for simplicity, we're going to keep it single user. I'm going to talk about multi-user capability at the end, but in order to explain how things work, it's just another complication that we don't need. Now, let's start with the implementation and provide the basic scaffolding. I guess this piece of code, I hope it's big enough for everyone to read, you should have seen a variant of this in essentially every single LLM tutorial that is out there. It's literally a variant of what you would get if you just go to the documentation on the OpenAI client and copy and paste it into your IDE. There is one thing to highlight here, though. I'm using the chat completions API. And OpenAI will tell you to use the responses API. The main reason for that is all of those third-party providers, they mostly support the chat completions API, and not everyone supports the responses API. And if you want to be able to kind of switch between providers, play around with it, sticking to the old way of doing it is the way to go for now. So we have the hello world of calls here. And we do get a couple of important building blocks for it. So for our agent, we have the messages list. This is the thing that will keep track of the state over time. We have the chat completions call, which is the thing that actually makes stuff go to the LLM and get its answer. And then we have some printing, because debugging is also nice. Now, a single call is not an agent. So we need to introduce a loop, something that pushes the progress forward. But here we get to our next pitfall. Here it's really obvious that this is an infinite loop, because we are setting that the work is not done, and we are continuing to do the work until it is done. But because we are not changing it, it's obviously staying an infinite loop. However, if we make it a bit more complex, if we have our things in there that do set the value, it can still be an infinite loop, because the LLM can decide to not want to finish the work, just keep on calling tools or something. And every single call to the LLM burns our money, whether that is in literal electricity because we're self-hosting, or because we are using a provider and every single call costs money. So we want, before we even go any further, we want to solve for that. So let's have a guardrail to limit the number of steps that it can go for. Because there's another speaker here, I think he is literally having his talk right now, where he said, well, we made it work, it worked pretty well. We wanted to make a bigger test, so we let it run overnight, and then it didn't finish. And when we came back, it spent hundreds of euros on just a single, on a single task, because the task didn't finish. So always have some kind of limiter that will limit how long it can go before you are like, nope, that's it, no more looping for you. I suggest to go with 10 iterations during development because it's quick. You don't have to wait for that long before it finishes. In production, I've seen it go up to 100 steps in more complex cases. But start small and grow bigger as you need. So now that we have kind of the basic setup, we have the scaffolding, let's look into the most important part, the thing that makes it more of an agent. Those are the sensors and actuators, and both are implemented by providing our agent with tools. And that essentially turns our agent into a REPL. This loop is a read, eval, print loop. It allows the LLM to run essentially a sequence of calls. It becomes essentially an interpreter for a programming language. And maybe some of you may be thinking, well, so what? Others of you may be like, oh, there may be a problem. This is the biggest problem of them all. Also because it's not as easy to solve. The problem is by making it so that your agent, the LLM, is essentially vibe coding itself to a solution and executing whatever it produces on the way there. So if you had allowed it to create code, it would be quite obvious. Oh, I shouldn't run this in a non-sandbox environment. But if you allow it to just call tools, you get to the problem where, well, it can call those tools in an arbitrary sequence. And everything in your context does affect what it is going to do. Your prompts, your users' messages, and there you can be quite certain that people have good intentions, especially if it's like an internal thing. But the results from executing tools is the thing that can really shoot you in the foot. Because let's take a look at what people are already doing, how they are already attacking the thing. If an attacker can change what your tools will provide by, for example, sending you an email or a meeting invite or filling out a form or any other thing where you might want to automate a tedious task, then they can effectively control what the context of the agent will be. And the mitigation is quite hard. Here, there was an article a couple of weeks ago where a group of researchers, of security researchers, took Microsoft's prime example of implementing an agent with its Copilot Studio and convinced it to send the entire customer database to the attackers over email by sending a meeting invite. So you have to keep in mind that the LLM chooses its actions based on its context. And if the context contains malicious prompts in it, then it may do things that you never expected it would do. Mitigation for this is really hard. There's no really perfect solutions for it. You can't just ask it to behave. It's like, oh, use common sense, don't send stuff off. Kind of some of those things were initially the approaches that people took. But literally days ago, researchers, I think at Anthropic it is, have noticed that, oh, you can essentially get through all prompt-based security measures by telling poems to it. Literally, lyrically phrase what you want the LLM to do, and it will get the idea. Our LLMs are actually really great at understanding ROT13 encoded text as well. So you can just push something in, and it will then, maybe not do what you actually wanted it to do. The thing that I suggest for this is to make your tooling a bit more defensive. So have an idea of what you are going to do or what you intend it to be used for. And then if the things that, if the parameters for the tools are something that you didn't expect, just don't execute it. If you expect it to send emails, and usually it sends just, a couple sentences or 2-3 paragraphs, then keep it limited like that, because an attacker will probably want to send a very large email with all your data. But as I said, it requires you to know what you're actually going for in this case. So now that the sirens, the warnings have worn off, we can actually get to implementing this. So next step is adding tools to the context of your prompts, right? To the context of the LLM. Here we have an example with a tool that's called Get Calendar Events. We have a description that explains what it does, when to use it, and gives an example for how to call it. So it's not just gets the calendar event. It's also use this if that, and here's how you use it. And then it goes on and goes for every single parameter. It tells it what type that parameter is and a description of how that parameter is supposed to be used. That's a lot of information. And as programmers, we often kind of get lazy about things like that. But if we do, that's the next pitfall. Because the LLM has no idea what this tool will do. It needs a descriptive name. It needs the explanation of what it is, when to use it, when it is appropriate to use. And if you don't, if you do something like Slack's MCP did in the beginning, where the description was just, gets a list of channel. It's like, what does that mean? What are the results of that? Or things like that. Then the LLM will simply not use your tool. And the problem gets worse the more tools you add to it. If you give it a lot of tools and has a lot of kind of possibilities, it will tend to use the tools that are well described more often. Now, then, once we have defined our tools, we've added it into the LLM context, we need to distinguish whether the response that we get is actually an answer that we should give to the user, or whether it wants to call those tools. And some LLMs will do one thing or the other. Some will want to call multiple tools at once. And some like to comment on the tools that they are calling. So you may get a mix of things. But this distinction points also where we have our exit condition, kind of when do we want to exit out of the loop. If it's just a message for the user, then there's no cool tools to call, and that's where we finish things up. So, as you can see by the line numbers, I'm skipping out through a couple of details that we'll look at in a moment. But distinguishing between those two types of things is rather simple. We check whether there are tool calls, and if there are, we will do some more stuff with it. But if there are none, we can just mark that the work is done, get the final response, and return that to the user. And let's take a look at what will go on in the execution loop. What we technically do is we get the response, we check whether there are tools, and then for every tool, we will execute it. But as we are executing it, we need to capture exceptions. We need to also capture when things go wrong. Because the LLM may have just used the wrong parameters, and it should try again. Or it may have failed so bad that it should answer to the user that it can't do whatever it was asked to do. But in any case, it needs to capture those error cases. And how does that look like in code? Well, first, we have a dictionary where we have just references to our tool implementations. That allows us to find the tools that we allow it to use and execute them. It's pretty simple. So if we can't find the tool, we tell it, well, there's no such tool, try again. If we do find the tool, we pass the argument as a kind of expanding arguments in here so that the keywords and everything are taken care of. And finally, we take the result and dump it into a JSON string so that the LLM can read that stuff. And as I said, we capture all exceptions so that we can pass on the error states as well. And then we've seen the implementation of this executable part here. Well, here's the loop for looping through the thing. We get the function name, we load the parameters from JSON, pass it on, and have a nice debugging print in there as well. And finally, we need to close the loop. So we need to update the state so that on the next iteration of the loop, actually something interesting happens. And we need to do that by adding a pair of messages. One is the original response from the LLM, and the other one is the results of the tool calls. And we need to keep track of the tool call ID so that internally it can align kind of the request with the response. Overall, it's pretty simple, right? So the completed thing is really not that complex. We have some initial setup of our state. Our prompt goes in there. We can make it a little bit more dynamic by telling it, for example, what date it is. Or later on, if you want to make it multi-user capable, we could add some rudimentary user information in there. We set up our preconditions for the loop. Then we start looping and check what tools we allow it to have. And there is kind of one thing in here, like a little detail that I skipped over before. When we are at the last step, it's good to not give it any tools at all. So it is like, okay, can't call anything. I need to come up with an answer right now. And then, as I've just explained, once we got the answer for all of that, we have our check whether there are tools. We run the thing, run the loop, or if there's none, we kind of finish it. So the agent, as I said, it's really not complex. So what about advanced capabilities? I like to talk about the multi-user capability. What would you need to do to take what I've shown just now and make it multi-user capable? As I said, you can add some information about the user into the prompt. But when it comes to the tools, you want the tools to be able to know what user is calling them, essentially, or for what user that is being called. But you never, under no circumstances, want the LLM to provide that user information. Because otherwise, someone, or maybe a malicious prompt injected through a tool, could convince it to just act as a different user. Instead, what you should do is to hard code that access, kind of where we had the tool call with the ** arguments. Just add user ID equals before that, so that, or rather after that, so it can never be overwritten by the parameters that the LLM passes. So don't trust the LLM to pass a user ID or things like that into your tools. Okay, so that's with multi-user capability. But some people say it's not a real agent unless it has memory. So there are many different ways how you could provide your agent with a memory capability. One way that I've used in my own frameworks before is that you can give them the tools to remember and recall. That allows the agent to kind of form its own memories and decide on its own whether it wants to remember something. It has to usually be really specifically prompted into doing that, because otherwise it is way too confident and it's like, oh, I remember. Because LLMs, they don't second guess themselves all that much. Another approach is enforcing it. So it's more of a RAG-like approach, where you, at the beginning of the interaction, you make a lookup into your vector database or however you saved your memories, and forcefully add it to this message list or even into the system prompt. And then, after it is done and has returned a response to the user, you can take the entire message list and transform that to create memories. That's a different approach. But as I said, it's quite simple in that you add something at the beginning and you add something at the end, and there you have memory. Then there are some people who are like, oh, this is a very simple agent that I've shown. There are those React agents that you can do with LangChain. They are actually not that much more difficult. All they do is they replace the simple LLM call, this one LLM call, with 3 LLM calls that go through different phases. Where they enforce a thought phase, kind of a reasoning phase, an action phase, and then an observation phase. In code, that is again super trivial. You set kind of the start phase, you replace the original system prompt with whatever you want, and this is very pseudocode. Like if you just copy and paste that, obviously that won't work, but the other things that I have shown should work. So, it replaces the first message in the list with an appropriate prompt for the phase. Then it calls out to the LLM, and then it adds the response to the state and kind of moves into the next phase. The same it does for the action phase, but there, kind of only in the action phase, it is also even allowed to use tools. And then finally, after it has used the tools, it can observe what has happened. And that turns the simple agent that I've shown today into a more complex thing. So, let's get to the conclusion. Is it all just a for loop? Well, there are many things that do very, very complex things in just a for loop. Your operating system, game engines, even literally your CPU, as it increments the instruction pointer and goes to the next instruction, next instruction, and next instruction. So, yes, it is just a for loop. It always has been, literally from the ground up, from your CPU through the operating system, all the way to the agent. But it's also a for loop with so many pitfalls. Essentially, every single line of code that I've talked about today has some kind of pitfall attached to it. So even though it is trivial to implement, we have to keep so many things in mind as we do it. So let's have a small summary of those pitfalls again, so you don't forget. First one is that you use an agent if you don't need it. Use a workflow, make something deterministic. Just call out to an LLM if you need it, if that will solve your problem. Then you might use a model that is not trained for your type of use. So if it can't use tools, it will be much harder to make it work properly as an agent. If you ignore the speed, cost, and capability triangle, kind of the trade-off that you have to make there, it will probably work really well, but it may also be really expensive to run. You could save, in some cases, 10 times the amount of money by just going to something that's faster and cheaper. Because why let the user wait a couple of minutes to do something that could have happened in a couple of seconds and save you money through that? Then, another money-burning thing is you could get into an infinite loop. As the LLM decides kind of whether it is done working or not, it could decide that it's never done, and therefore it would never finish and burn all your hard-earned money. And we can be lazy about writing our prompts and our tool documentation. So if we don't provide it with an appropriate context to do things, it won't do them as well. And very often that shows in behaving not quite as, well, deterministic is really the wrong word to say, but not as reliable, right? Sometimes it will just not want to use your tool or always pass the wrong parameter. And that can be handled by improving what you put into its context, be that a better documentation of the tools or better prompts itself. And then finally, the thing where it's really hard to really solve for it right now is that it is technically possible to inject things into your prompt from the outside world if your tools are not hardened against it. So maybe if it's going to read emails, don't give it the entire email if it's just the overview. Or if it's capable of sending emails, don't allow it to send a bazillion emails at once or huge emails or things like that. So, some final thoughts here before we go to questions. Frameworks hide many of those pitfalls by making the learning curve seem more shallow. If you look for something like a LangChain tutorial, you can see that you can create an agent with literally 15 lines of code. But then as you try to do more with it, as you maybe try to figure out how the internal prompts work, how to change them, you suddenly have a new pitfall, because now you need to get a PhD in that particular framework to be able to do something about it. If you started off with something that you already understand, a simple program that's maybe a couple hundred lines of code, then you can change it, you can debug it, and you can work with it in many different ways and take the evolution of your agent in whatever direction you want to. So that with all the things that I've shown you today, you should be able to really confidently go about your work creating AI agents or not creating them and explain why you don't do that, why it is a better idea to do something different. So now we have plenty of time for questions and discussions. You can ask now. You can also find me later in the hall. For people that prefer talking through a screen, you can add me on LinkedIn or send me an email. And in any case, thank you very much for your attention and enjoy the next talks. So, any questions? Okay, let's start at the beginning.
Thank you very much. I was struggling explaining to my colleagues when I talk about an agent or an autonomous agent somehow, because when I started playing around with the agent frameworks, just to get an understanding, I was then in favor with LangGraph because it was easy to use. I could plug in my own Python code and so on and so forth. And I realized, well, what I do there is just prompt chaining.
Yeah.
And then I framed it, okay, I'm running an agentic workflow. But I would be very keen on your thoughts on this, how to frame it, so that I do not do the... Communication is difficult these days.
Oh, yeah, very
because
much so.
all of the people around me use the term, and some of them don't know nothing about it. And that's tough for me to explain, and I want to call it agentic if it is using some technology, but if I know it's just prompt chaining, I think I'm misleading them, and it's a bit tough.
Yeah, it's so because everyone is calling everything agents these days because that's what gets them funding. It has really been like a very muddied concept by now. In principle, even this, in a way, is prompt chaining, right? Because we're sending stuff over and over to an LLM. But in doing so, we get back things that actually execute stuff. So if what you're doing is not executing anything, or is only kind of integrating with the world in a read-only way, then it's more of a kind of agentic RAG situation. Whereas if it can interact with the world, if it can change its environment in some way, that's where it gets agentic. Then the agentic workflow thing is a bit of, well, there's a bit of nuance to it. So you can have workflows that are triggered by an agent to interact with the world. And you can have workflows that use LLMs to process data. One thing is, again, interacting with the world. That makes it agentic. The other thing is just a workflow that is using AI as a processing step. So I think, at least for me, that makes the distinction quite clear. If it can interact with the world in a way that changes it, then you can call it agentic or an agent. If it is just processing, then it's not.
That helps. Thank you very much.
You're welcome. Anyone else? Let me go to this side and then to you.
Yeah, thanks for the talk. Can you explain a bit more about agent to agent?
What do you mean? Agentic agent?
Yeah, so right now the example is more about agent calling a tool. So is there a case that agent can call another agent? And then there will be a whole orchestration of different agents working together.
Let's bring the spaghetti code up again, because it is the best thing there. So what you're talking about is when you have a situation where you want agents to cooperate. Yeah, that is quite useful because the way how this was implemented, it has kind of a bonus pitfall here. If you have a lot of tools, it can get confused because it kind of loses its identity. It doesn't really understand what role it is playing. And what you would want to do then is create a couple smaller agents that each has a more strictly defined identity and has a subset of tools. And then calling a different tool is essentially just, calling a different agent is essentially just calling a tool with a prompt and some context for it to do the task. It's literally delegating a piece of work. You can make it so that those things can run in parallel, so it is kind of faster. But introducing concurrency into this whole thing makes it even harder to debug. So don't start off with that. Also, don't necessarily start off with the multi-agent idea to begin with until you get to the point where it gets confused. Because if it, if it takes on the role of a librarian, for example, there are many things that a librarian can do and that it can understand. So it doesn't necessarily need to be broken up into a guy who sorts books into the shelves and a guy who, accepts them at the counter or something like that.
Got it. So it's kind of the opposite of object-oriented design. So we start with a very giant agent that does everything until you see agent got confused. You probably start to break down into sub-agents.
Yes, it's kind of like if you start working in a domain that you don't fully understand yet, decomposing it into objects can be a bad idea because you have no idea how to decompose it yet, what makes sense. So you go with a structured programming approach instead of an object-oriented programming approach first. And then as you learn and understand how things naturally interact, then it can make sense to pull them apart.
Thank you.
Okay, let's move on to the next question then.
Yes, thank you, Paul. Very interesting. Can you speak to the size of tool responses? So it adds to context, and I would be interested in some strategic advice.
In principle, go for the smallest possible. So that is just put in the things that it needs to do now and give it a tool to go for details later. I have, was it last year or the year before that, I've given a talk here at MLCon Berlin about an agentic RAG thing, where it could search through the German text law by just using a SQLite. And you don't want to, throw the whole law at it. It would not just fill up the context and make everything really slow, but it would also confuse it. So for that thing, I allowed it to search, and it gets just snippets with about 100 characters of the results. And then it can either go for a table of contents to see kind of what else is in that law, or it could go and ask for a specific paragraph. And then the tool responses are kind of self-contained, small enough. If it thinks that it needs kind of things, anthropomizing the thing here, but if it gets to the point where more information is required, it can usually get there. And if you prompt it to work on as much information as possible, it will usually do that. But giving it too much information at once is a good way to get it confused. And it's also a good way, if some of that information comes from the outside, to get it prompt injected. So to answer your question, it would be best to have the least amount possible in your tool responses. Be as small as possible. It needs to be a convenient way for it to interact with it, and not necessarily a lazy way for the developer to save some time by just giving it everything in one call and say, well, it will figure it out.
Yeah, thank you. So I understand it like this, that you say it is cascaded and let the tool decide to what level of granularity it wants to go.
Let the kind of LLM decide.
LLM decide, yes. Okay. Thanks.
And sometimes that it is kind of a bit of a more complex way of designing things, and you will need a more capable LLM to do that. Sometimes you can give it a parameter, like your tool have a parameter that can take either a JSON path or an X path or something like that, that allows the LLM to select what information it wants out of a bigger structure on its own. However, that can be quite brittle. So I would suggest kind of staying with the simple approach of, like you as the developer know how big the thing is.
Okay, thanks.
Okay, more questions? If not, I think it's going to be lunch break or something next. So, I guess have a good break.